In lesson 11.3, we're going to look at geometric sequences. We've talked about arithmetic sequences, and then we dealt with series. Now we're going to get into geometric and how they're different than arithmetic sequences. Here's an example, not in your notes, but if just take a look at if you've ever bounced a ball. You know that when you drop it, it never rebounds to the height from which you dropped it. Suppose a ball is dropped from a height of 3 feet. Each time it falls, it rebounds to 60% of the height from which it fell. The heights of the ball's rebounds form a sequence. So they're kind of giving you a graph here. It's always rebounding 60%. Now, obviously, due to gravity and stuff, eventually the ball's going to stop. But if it's always with 60%, it would never actually get to the ground unless they're, but because of gravity, it does. So let's go to the next page here, which is actually where your notes start. Geometric sequence. And you need to write down the definition that I have in blue here. It's a sequence in which each term after the first is found by multiplying, so this is key, the previous term by a constant r. We use the variable r, which is called the common ratio. So r is the common ratio in geometric sequences. Okay, it's what we multiply by to get from term to term. Now, that sometimes could be a fraction. If it's actually a decreasing geometric sequence, then r could be a fraction. We're multiplying by a fraction, which is like dividing. Okay, so let's uncover this for you. Oops, I need to get back to my arrow. So, actually r is found by this. A sub n, and then this should be a with the subscript n minus 1. That 1 is in the subscript, so this n minus 1 is the whole subscript. That's to take a term, so basically, to kind of tell you what that means, a sub n, you're going to take a term and divide by the one that's in front of it. A term divided by the previous term that's in front of the one that you pick. And we'll do that here in a second. I'll show you what that means. But that's not really necessarily a formula you have to write down. I would just write down that to find r, you take a term and divide by the term in front of it, or the previous term. So find the missing term in the geometric sequence. If we think about this, you kind of have to know what's going on with the sequence here. Let's actually show you finding r. So I am going to take a term here. I'm going to take this one. Now you can't take the first term because there is no term in front of that to divide by, but you can take any term. I'm going to take 12 and I'm going to divide by the term in front of it, which the term in front of it is 36. That's what this is saying, how to find r. So 12 divided by 12 divided by should be 36. I wrote 12 again, which is equal to 1/3. So what this means is r is 1/3 in this sequence. That is the same as dividing by 3, but we always say, what do we multiply by? If it's a decreasing geometric sequence, r will be a fraction. So r is 1/3. So to find this next term right here, I have 12 and then blank. I'm going to take 12, I'm going to multiply by 1/3, which is going to give me 4, which is like 12 divided by 3. Okay, notice if I would have took, to find r, if I would have took 108 and divide by 36, if I would have took 36 and divided by 108, that would also reduce to 1/3. If I would have took 108 and divided by 324, so you can take any term and divide by the term in front of it to find r. That's the key thing here. All right. To find a particular term, you're going to use, it's called the explicit formula, but this is the formula. A sub n equals a1 multiplied by r, and then the power on r is n minus 1. This is the formula that you'll be using to find a particular term in a geometric sequence. This is for geometric now that we're dealing with. Okay, you kind of had an nth term formula for arithmetic. Now we're going to have one for geometric. Okay, that's the explicit formula. Remember these things, kind of the same notation terminology as arithmetic sequences where we're adding between terms. A1 is first term. A sub n is to find the term you're finding. Okay, or the last term. Like if I'm finding the sixth term, it would be A sub 6. N is that number of terms that you're finding then. Okay, so here is that formula right there. Okay, formula we're going to use. Now notice what they're giving me here is A1 is 3, or negative 3, and R is negative 2. That's the given information. And they want me to find the sixth term. That tells me I want to find A6. So let's use this formula. To find A6, which means n is equal to 6 because there's a 6 in that spot, I take A1, which is negative 3, and I multiply it by R, which is negative 2, to the n minus 1 power. So that would be the 6 minus 1 power. So A6 would be negative 3 multiplied by negative 2 to the 5th power. Now you got to think about order of operations here. I don't multiply, I have to do the exponent first. So negative 2 to the 5th power, negative 2 times negative 2 times negative 2 times negative 2, 5 times together, is negative 32. So I'm really multiplying that, which tells me my sixth term is 96. Now, you're only finding the sixth term, so if you think about this, you could start listing out the terms. But you have to know how to use formulas. For instance, A1 is negative 3, and we know this is what we multiply by, negative 2. So if I actually took my first term, negative 3, and multiplied by negative 2, I'd get 6. If I took that times negative 2, I'd get negative 12. If I took that times negative 2, I'd get 24. If I took that times negative 2, I'd get negative 48. If I took that times 92, or times negative 2, I'd get 96. Notice, this is A1, A2, so on, A3. This would be A6. You can find them listing out the terms. Now, if I said find the 100th term, I don't think you'd want to list that out to 100 terms. So you have to know how to use the formulas and understand the notation. Write an equation for the nth term of a geometric sequence. And let me move the timer here. Let's move this down. Here's the sequence, 5, 10, 20. Now, you can see this is geometric because we're multiplying between terms, but we want to find the nth term, write an equation. So that means we're going to use this, an equals a1 times r to the n minus 1. The n's going to stay in there, okay? We're going to actually plug in a1 and plug in r. So a1 is first term, that's 5. To find r, I take a term. I'm going to take this term, 10. I'm going to divide by the term in front of it, which is 5. So basically, r is 2. That's what I'm multiplying by between terms. So here is my equation for the nth term. I'm going to say an, and that's going to stay an. We're just writing it in terms of n. It's a1, 5, times r is 2. Now, when r is a positive, I usually don't put it in parentheses, but you could, to the n minus 1 power. And you cannot go any further with simplifying that right-hand side. You can't multiply 5 times 2, because if you knew what n was, you'd have to actually do the 2 to that power first and then multiply by 5. So that would be what they're looking for there. Find a term given the third term and the ratio. So we're going to find the seventh term. That tells me I'm trying to find A7. We're given the third term, and we know what R is. Okay? Show you a couple different ways to do this. We're going to find A1. We're going to work backwards and find A1. So I'm going to do A sub n equals A1 times R to the n minus 1 power. Now, here's what we're going to do. We know the third term. So A3, okay, which is 96, is equal to A1. Well, we don't know that. That's what we're going to try and find here. Times R, which is 2, to the n minus 1 power. Now notice this right here is in for the n. That tells me that n is 3. So we do 2 to the 3 minus 1 power, which is really going to be 2 squared there. So if I'm solving this for A1 algebraically, 2 squared is 4. So I have 96 equals A1 times 4. I'm going to divide by 4. So A1 is 24. I kind of used the nth term formula for geometric sequences, worked back, found A1. Now we want to find the seventh term. So I'm going to rewrite the formula for finding any term. Now I'm going to be finding A7, which obviously means n is equal to 7. This is key, knowing what that subscript means. A1, which we now know, is 24, times R, which hasn't changed, that's 2. If you want to put it in parentheses, you can. To the n minus 1 would be 7 minus 1 power. So I'm finding the seventh term, A7. I'm going to take 24 times 2 to the 6th power, and find 2 to the 6th, then multiply it by 24. You could do that with the calculator. That should give you 1,536. There's my seventh term. Now, could I have done, okay, A3 is 96. I know I'm multiplying between terms. Could I have then multiplied that? Took 96 times 2, found A4. Then find A5, multiply whatever this is by another 2, and gone over to A7. You could have done it that way too. But like I said, if they would have said find A100, I don't think you're going to want to list it out to 100 terms. So knowing how to use the formulas, sometimes working backwards in the formulas, is key here. Alright, then we get into geometric means. Very similar definition. It's the missing terms between two non-consecutive terms of a geometric sequence. Similar to what we had with arithmetic means. You're finding the blanks in between two given terms. And they're telling us it's geometric, okay, and we're finding 3 in between. So what this really means, let me uncover this, is the first term is 3.12. 49.92, and then there are 3 blanks in between them. So this is A1. If there's 3 missing terms, this would be A5. It would also mean that this is, in this case, the last term, because we're going to use the formula. So we're going to find R. Let's write the formula down. AN equals A1 times R to the n minus 1 power. So over here, we're actually going to put A5, which means n is equal to 5, but we know what A5 is. It's 49.92. A1 is right here, 3.12, so that's going in for A1, times R to the, I got to do n minus 1 power. Now notice n is 5, so if I actually took to the 5 minus 1 power here, I'm really doing R to the 4th power. Solve for R. So I got to get rid of multiplying R to the 4th by 3.12. So I divide by 3.12. So R to the 4th is equal to 16. And this is key. So if I have R to the 4th is equal to 16, that's what I'm left with. Now I have to do the 4th root of both sides. Okay, So r will equal, so if I do the fourth root and I do the fourth root, because it's r to the fourth power, fourth root of 16. Now, if it's an even root, you need both a positive and a negative root. If I was doing a square root, a fourth root, a sixth root. If it's an odd number root, you don't need positive and negative. So r would equal either positive or negative 2. And this is key. When it's an even root, it's going to produce two sets of geometric means. And you might be saying, what do you mean by that? Well, here's what I mean. We could be multiplying by positive 2 or negative 2. So when you list answers, here's what I would do. If I multiply by, when r is positive 2, the geometric means, we're finding these three missing values. I would take 3.12, multiply by 2. So it would be 6.24. And then the next blank, this one right here, multiply by 2 would be 12.48. Multiply that by 2, it'd be 24.96. There's one set when r is equal to 2. But now I have to do negative 2. And the only thing that really changes, and again, this is only when you have an even numbered root, okay, multiply by negative 2, then this one is going to be negative. Okay, it's still going to be the 6.24, but now if I take negative 6.24 times negative 2, this one is still going to be a positive, just like in my first set of answers. But now I'm going to take 12.48 times negative 2, that's going to make this one negative. It causes the signs to alternate. So I have two sets of geometric means, and this is a common mistake that I see people forget to put the negative on there when they're doing an even numbered root. Okay, so make sure you are aware of that, which would create two sets of geometric means.